Okay guys, welcome back to Coaching Mathematics. It's Coach Rob here. We're trying to get into a little Pythagorean Theorem and show you guys what you can actually do with using Pythagorean Theorem. And so we're going to start out here with, you see I got three basic triangles, so we're going to go through three different things we can do with Pythagorean Theorem. So let's take for example that with this first triangle here. The first thing you notice is there are three sides to this triangle, okay? A and B are considered legs, where C is considered the hypotenuse. Now, here's the thing. The hypotenuse, the reason we know it's called the hypotenuse is always across from that right angle, okay? It's always the longest side to that triangle as well. So we always recognize the hypotenuse to the triangle as being across from that right angle. So let's take for example that we have two sides to this triangle. We're trying to find a third side, and let's say that third side is C. Alright, so I'm just going to put some numbers in here. Let's say A is 4. Let's say B is, we'll go with 5. Alright, so we want to find out what C is. Okay, so we're going to plug into Pythagorean Theorem. So A squared plus B squared equals C squared. Well, we can find the third side of this triangle using this formula. So let's start out, we're going to plug in 4 for A, 5 for B, C we still don't know. Alright, now if you notice there's little squares up here. Alright, so there's a square there on each one of these. Okay, so when we actually plug our numbers in, those squares go along with it. Okay, so what that actually means is we're going to square each number. So 4 squared would be 16. 5 squared is 5 times 5, is 25. And then that equals C squared. Okay, now what we want to do is we want to plug this into our calculator here. Alright, so we got our calculator, and we're going to do 16 plus 25, which is 41. Alright, so what I want to do is write down 41 equals, I forgot my 2, C squared. Okay, so now that I have 41 equals C squared, alright, so what that's telling me is that if whatever number I can square, in other words a number times itself, that'll give me 41, that's what I'm looking for. What would that number actually be? Okay, well, to do that, if you'll notice on my calculator I don't have a square root button, so I'm going to put this in scientific mode. And if you'll notice up here at the top, well, right here with the little 2 above the square root, that's your square root symbol. Okay, so if you're on an iPad or a calculator, you have these symbols in your calculator. So what we're going to do is we're going to take the square root. So once you hit the square root button for 41, we're going to hit enter. So we got 6.40. Okay, so you can round this to whatever you want to. So normally I have my students round this to the nearest tenth. So that means that 6.4 is C. Alright, so right over here I can write equals 6.4. Okay, so that's one way of doing it. Now, let's look at this other one, number 2. I'm going to plug in, I'm going to say this is my A, this is B, and we always know that's C. Now, one thing you want to remember is this A and this B can be interchanged. If I wanted to erase that A and that B and change them up, so in other words I wanted to put B here and A there, I can. That's not a big deal. It's still going to work out the same. The main thing is that we got to make sure that we do not get C mixed up with either of the legs. Okay, C always has to be in the place where the hypotenuse should go. Alright, so now let's use some different numbers this time. Let's say that we have B, and let's say that B is, we'll go with 5 again. Alright, so B is 5. A, we're going to say we don't know A. Alright, so we're trying to find what A is. Let's say in this case C is 10. Alright, so we want to know what A is. Alright, so we're going to use the same formula. A squared plus B squared equals C squared. Alright, and I'm going to plug in my numbers here. So A, I don't know. B is 5, so I'm going to put in 5 make sure I square it, make sure I put my square up there, and then put 10 in. Okay, put my square above it. Okay, so again, you notice that I have my squares on all three of these, okay? Which means to continue working the problem, I must square both 5 and 10. All right, so a squared plus 25 equals 100. All right, now I want you to notice something. In the first problem, okay, so over here on the first problem on number 1, I want you to notice right here there was a plus sign, okay? So we added 16 and 25 on problem number 1. All right, now I want you to look over here at problem number 2. I do have my plus sign. However, I don't have anything to add to 25 because I don't have an a squared, okay? So this is where number 2 is a little different from number 1, okay? And the rule that I try to teach my students is anytime you're missing a or b, if you're missing a leg, you must subtract your two numbers, okay? So right here we would subtract 25, okay? So we come over to the other side. Whatever you do to one side of an equation, you always do the same to the other. So if we're going to subtract 25 from the left side, we're going to go across that equal sign and subtract 25 from the right side. All right, so what that gives us is a squared is equal to 75. Okay, now we're not done because we're still trying to find what a is. We know what a squared is now, but we don't know what a is yet. All right, so in my calculator, what I'm going to do is I'm going to take the square root. All right, so the square root of 75, so I put in 75, take the square root of that, 8.66. All right, so the square root of 75 in this case would be 8.7. So we found a to be 8.7 in that particular problem. All right. Okay, for number 3, we're going to talk about whether a triangle can actually be a right triangle or not. All right, so I'm going to put some numbers in here. Let's go with a being 6. Let's say that b is 8. And then let's say that c is 10. All right, so if we want to actually determine, well, first off, you notice that in problems 1 and 2, we were actually missing one of the sides to the triangle. Well, in problem number 3, we're not actually missing one. We're asked a different question. The question is, can this be a right triangle? So we still use the same formula. A squared plus b squared equals c squared. But what we want to do is we want to plug in the numbers where they go. So a and b is interchangeable, so that doesn't really matter. So I'm going to put 6 squared and 8 squared. But c squared has to be in the correct spot. Okay, so 10 has to be where the c is. All right, now let's just work this out. So I got 6 squared is 36. 8 squared is 64. 10 squared is 100. All right, so let's add these two. 36 plus 64. Well, let's see. 36 plus 64. Okay, I got 100. So 100 equals 100. All right, so when you get to the end, you ask yourself, first off, notice I didn't have to take the square root. Reason being is there's no reason to find your square root because you're just squaring the numbers up top to see if they equal the same thing. So once you add 36 and 64, you look to see, does that equal 100? Well, in this case, it does. So if it does equal itself and they come out to be the same number on both sides of the equal sign, then this is a right triangle. So we answer the question as yes. This is a right triangle. So just to recap, if the triangle is actually a right triangle, when you plug your numbers in, making sure that C is in the correct spot, and you do your squares and adding the two A and B together, if they come out to be the same on both sides of the equal sign, then that makes it a right triangle.